All right. Hello, everyone. Welcome to our second webinar. This topic today is going to be about NETCONF and YANG automation testing. I'm Nabil Mishraf, Solution Architect with TLF. And we have here Wei, my colleague, who will be doing the presentation. We organized this presentation today in two sections. First part is going to be presentation of slides, and then we'll have a short time for or 10 minutes, around 10 minutes for questions, and then we'll move to the demo part. So a couple of things I would like to point out before we start. On the right side of the WebEx, the main WebEx window, you'll find the Q&A tab. You can ask questions using this Q&A tab. You'll also see a chat tab. Don't use chat for questions because it's hard to track answers. So focus on the Q&A. If you have any questions, please use this Q&A tab. My colleagues will be able to either answer the questions, or Wei will be able to answer the questions verbally. So we'll focus on that for questions. And then towards the end, we'll have some time to ask if you have any other questions in addition. So feel free to post your questions as soon as you have them ready to this Q&A area. I will make the recording and the presentation available at the end, so you'll be able to access those. What else am I missing?
Yeah. I need to leave and come back in because I'm not able to share my screen. I'll be right back.
Oh, yeah, that's fine. We have some time for the next part here. I have a few questions. I'm going to start the poll, and I would love for you to answer these few questions, poll questions. So I'm going to keep it open for 5 minutes, but you can basically answer it in a few seconds, just 5 questions. So I'll open the poll now. Hopefully you'll be able to see that as well on the right side of the WebEx window. And while we wait for Wei to join us, Wei,
I'm back. Can you pass me the ball again?
Yeah, sure. Okay.
I am able to share now. Okay, great.
Okay, perfect. And I started the poll, everyone. So please, if you could answer those 5 questions for us, that would be great. We can share the results after the end of the time limit, which is about 5 minutes. And while you're doing that, Wei, I think you can start.
Okay, thanks, Nabil. So hi, everyone. Hope you have a good day. So I'm going to talk about NETCONF and YANG automation testing, and my name is Wei Tai. So here's today's agenda. I'll talk about why I think it is important for you to be doing NETCONF and YANG automation testing, and then you to our NETCONF and YANG automation testing program that we are making available to you. And then next, I'll go into describing the tools that are going to be involved that we are making available to you to use to do the automation testing. That includes NSO, the NETCONF Net Builder that comes with NSO, the .NET Examiner test tool that allows you the ability to do the automated testing, as well as some resources on YANTIC and our program. If you're not familiar with YANTIC, it stands for European Advanced Networking Test Center. The activities that they are involved in is very relevant to NETCONF and YANG interoperability testing across different vendors. So I'll talk about it when we get there. And then we'll have a Q&A session followed by a conclusion of a couple of demos to show you the kind of things that can be caught during your testing. So now that you have your NETCONF and YANG implementation either under development or ready, so how do you go about testing it, right? So is it enough to just do protocol level testing for RFC compliance? Well, in your case, I'm sure a lot of people would likely choose a toolkit or framework that already supports NETCONF and YANG that you would use to integrate into your products. And in those cases, you hope that the toolkit and framework products that you have selected have already done this for you. Or on the other hand, if you're doing it from scratch, then certainly this is something that you would have to do. So it's certainly necessary, but it's not sufficient, right? Now, then is it enough to be able to respond to NetConf RPC calls? Well, I'm sure a lot of you would be making use of perhaps open source NetConf clients, such as NC clients, in order to send the RPC request to your NetConf-based products. And then you would honor the request, handle or take the action necessary on the back end, and then provide with the RPC reply back. And certainly a lot of those kind of NetConf clients, they only check your RPC reply, right? They don't check anything else beyond that. So if you are only looking at a request and reply basis, there are a lot of things gets overlooked, right? So certainly this is a must that you have to do. You have to be able to respond properly to any NetConf RPC request, but you need to go beyond that. You can't just stop there. Now, when it comes to the question of, well, is your implementation ready for service automation? Well, one of the biggest benefits of going to NetConf and YANG is that it really gives you the ability to allow networking products to be fully programmable in the entire network. In the world of intent-based networking, it's really important that all of the networking products that are available out there that should be able to just take a request and be able to run with it. And whichever orchestrator manager products out there, they shouldn't have to know any specific behavior of your networking device, and they shouldn't have to write any special code in order to deal with different vendors' devices. So if all of the NetConf-based products would just behave according to the way it's specified in the RFCs, as well as taking care of the updating your data store contents correctly and the transactions, then you would be able to allow your product to be fully automated. We really want to strive for the highest level of automation that's possible. So one of the best way to do that would be to test with a service orchestrator, right? You can certainly would start with testing with NSO, and you're free to, or actually you're encouraged to test with other service orchestrators as well, perhaps by participating in the ENTIC test events that would allow you to be able to interoperate with other vendors' product as a result of those kind of testing that you do. So what is out of scope for our program? So the acronym for our program is NIAT, NetConf and YANG Automation Testing. So we don't automatically generate the test inputs for you. We don't go through all possible permutations of each data node, leaf values, and so forth. And all of those you can certainly do during your development, perhaps during your unit testing or integration testing. As far as boundary condition testing is concerned, If that's important for you, that you would like to make use of our test tool to do that, you can certainly define test cases using those boundary conditions, making sure that your products can behave properly under those conditions. Now let's talk about service automation criteria. We talk about, okay, the importance of making sure that your products can be easily automated, especially with service orchestrators or OSS managers out there. So the basic criteria that you should strive for would be making sure that your NETCONF implementation has supported the mandatory basics. They include the hello, locking, and subtree filters. And you also need to make sure that the YANG models are correct and compliant with the RFC, right? The syntax is correct, that the constraints are reasonable and as well as correct, that you're expressing the constraints properly. You're not expressing the constraints in such a way that it can never be met. And then you choose the proper data types accordingly. And there are also plenty of standards-based YANG models available these days that you are free to use. And in fact, you're encouraged to use those instead of creating your own, if those standards-based models are relevant for the space that you're in. And then lastly, the transactionality of your implementation. You need to make sure that the all or nothing semantics is fulfilled. That when an edit config request comes in, anything that's specified in the payload, either they all gets committed into your data store, or if anything goes wrong, even if it's just one attribute, one of 100 that didn't that would cause a problem for you for your device, then you should roll back the entire transaction that go back to the previous state. And then the all at once semantics, meaning that there should never be any sort of order dependence within the transaction. So whether you send the order of A, B, C, or C, B, A, they should have the same result. And the configuration validity can only depend on the configuration alone. You cannot tell your clients, your NETCONF clients, that, okay, this particular configuration state is only valid if certain operational state is fulfilled. That is just not acceptable. And lastly, no auto config. Whatever is specified in the payload of the edit config request is what should be changed or modified in your data store. If you do anything extra, those are considered as auto-config or side effects. They will confuse the managers, the service orchestrators out there. Whenever they try to compare the difference of what they have in their data store versus what is on the data store of your device, and if they don't match, then that's going to cause automation nightmare, right? So the whole idea of requiring all these criteria to be met is that we want to eliminate the custom error handling code that needs to be written on the service orchestrator or manager side. And also we want to avoid having to write special code in order to deal with a particular device implementation on NETCONF, because that particular implementation behaves differently. So sequencing, so yes, let's elaborate the transactionality a little bit more. So sequencing and admin status. So a minimal delta must only refer to any particular leaf once. You cannot first set a leaf to one value, then set it to another value, right? So we have to make sure that there's no dependency there. And then it's a set of changes and it's not a sequence. So again, back to what I said earlier here, that you can't have for you first set this and then that before you do anything else. And then the devices will need to properly sequence the work to reach the desired configuration, meaning that, okay, the transaction itself is order independent, but then if your backend code requires some sort of an order before you can execute or carry out the action, then you will need to make sure that the order is being maintained after the transaction or at the end of the transaction. It should never be that you should never push the intelligence to the NetConf clients or the human being or the human users. And the modes which traditionally have prohibited changes in the CLI world is quite popular in the old days. That there's such a thing called the admin status, that you have to set it in a particular state, perhaps up, before you are able to configure anything else for a particular interface. So those sort of semantics are no longer acceptable when it comes to NetConf and YANG. So validation dependencies. So again, if a configuration has been valid in the past, it must still be valid now, right? So if I was able to get to state C2 sometime in the past, and if currently I'm in state C35, I should be able to just figure out the deltas, the differences in the configuration between C2 and C35, and include that in the payload of the edit config request to be able to transition from C35 to C2 without any errors. So that is something that would make it so much easier for a manager to be able to manipulate the configuration data store of your NetConf implementation without having to worry about, okay, well, is there anything special about this device that I need to be aware of before I can do this? And then there's the no auto config in edit config. So if a manager is thinking of sending out a couple of actions, right, or making a couple of changes, or asking the workers to carry out a couple of orders, if the instruction says order 41, 42, and 43, okay, if they are being sent to 3 separate workers, the first and the third carry out the order exactly as specified, as requested by the manager. But then if the second one deviated a little bit, okay, I want to do better. I'm going to do something extra and modify something for free. Now that is called an auto config. You should never do that, because then if after the changes are made on all of the networking devices, if the manager sometime in the future try to see the differences between what is contained in its own data store versus what is contained on the device, if there are differences, it's going to think that, well, maybe someone went ahead and made some changes, right? So it's certainly going to cause confusion. It's going to create a nightmare if you try to automate the entire network. So let me introduce you to the NetConf and YANG automation testing program, the NIAC program that we are making available. It's designed to equipment vendors. Yep, go ahead.
Since we finished one of the agenda topics, would it make sense to take some questions?
Sure, if there are some that I can, yeah, sure, yep.
Right. So there is one assigned to you. You could start with that one.
Okay, I will need to start my sharing.
Yeah.
Right?
So It's okay. Don't. Okay, that's fine. But basically, it's the question is, how does NETCONF and YANG automation differ from Ansible network automation?
Okay. Well, with Ansible, what we have noticed that's happening is that Ansible can sit on top of a service orchestrator, such as NSO, and there's a very strict recipe that Ansible will push down to the orchestrators. There's really no intelligence behind that. So there's no sort of a feedback loop between Ansible and the service orchestrator. It's sort of a one-way order. But when it comes to communication between the service orchestrators and the devices, it's a more so of a back and forth that, okay, if a transaction does not complete, it will then roll back to the previous state, right? In the case of Ansible, I don't think it's got logic that would handle that kind of a rollback condition. Whatever recipe that is sent down to the orchestrators, it assumes that those will get executed. So that kind of automation is not very intelligently based.
Perfect, thanks.
Mm-hmm. Okay. So let me go back to talk about the NIAC program. So it's a free service open to equipment vendors. I got a URL here that talks about the program if you're interested to learn more about it. And what it provides you is that NSO is freely downloadable for non-production use. You get to use the NetConf Net Builder that comes with NSO, and then the .NET Examiner automation test tool, as well as technical support via email by myself and along with my colleagues. And what you need to contribute is that you need to bring your products that you would like to be tested. And you need to allocate a machine or, well, at least part of a machine to host NSO and .NET Examiner. And you want to decide one or more use cases that's testing. You certainly want to choose the one that's most common for your products, and then a couple of typical configs to go along with each one of those use cases. So the participants that we expect for this program is really open to everybody as far as the tools that we are making available, as well as the documentation. But when it comes to support, because of the limited resources that we have, we will only provide a technical support for equipment vendors. And if you happen to be a service provider, we really encourage you to talk to your equipment vendors and get them to participate in this program. The more interoperability that we have available out there, the more things can get easily automated down the road. So what would be considered as the minimum success criteria? So certainly don't aim for the sky. It's not like code coverage that you want to reach, I don't know, 90%, 95% code coverage. So you want to start small, right? You select one or more common use cases for your product. And then for each use case, you define a day zero base configuration. So maybe your product, after it's shipped, when it gets initialized, that may be the state that you want to use as the base configuration that everybody would sort of start configuring. And then a few day one running configurations, right? Those will be the configuration that your end user will want to set up in order to utilize the services being supported by your networking products. And then we call those the test cases. Then after you define all of those, you will use .NET Examiner tool to record those configuration test states. And after all those test states are recorded, then .NET Examiner will be able to go through all possible permutations between the state transitions from one state to another. And if all of those succeed, then it's a success. And here is how we see the process flow will look like when you are participating or when you are making use of our program. So your NETCONF and YANG development will use the service automation criteria as input or as requirements. And then we see this as a iterative development process, right? If you're brand new, you're just starting, maybe your product only has a few YANG models to begin with. So you start with those. You will build a NETCONF net with those YANG models that you have. And then you define the test configurations for the use cases that are supported by those set of YANG models. And then you would use the .NET Examiner in order to go through all of those transitions to make sure that the transactionality behavior is correct. And then the other thing the NETCONF Net Builder gives you is if you have any sort of a YANG definition issue, those will be caught by the NETCONF Net Builder. Then when everything's all done and passed, then here comes your validated use cases. So now let's talk about the test tools that we are making available, right? So NSO is a service orchestrator, so I'll start with that. So here's a high-level overview of NSO. NSO provides network-wide orchestration across multi-domain, multi-vendor, and multi-layer products, networking products. And it provides centralized policy and services. And you certainly don't need all of NSO in order to do your testing. So what we will be focusing on would be the device manager piece of NSO. So what the device manager gives you is the multi-vendor abstraction through this net component. So on top of the device manager, what is being seen by the service manager when it tries to automate services across the network is an abstracted layer defined by YANG models. So regardless of the southbound interfaces supported by the device manager will abstract it as a YANG model. And then they will all be presented to the service manager in the same way. And all of their configuration and operational data will be stored in NSO CDB. It's an in-memory database that's also persistent on disk. So as far as the service manager is concerned, everything looks the same to NSO. And the magic happens is with the net component, the network element driver component. And let me move on to the next slide to talk about the differences of the different network element driver components that can be supported by NSO. So what we have seen in the history of the telco business is that the number one killer is really the adapter tags, right? We have gone through so many evolutions of CLI, Clover, SOAP, REST, TL1, and now we have NetConf. And one of the biggest benefits that I've mentioned earlier is that with NetConf, when you're working with NSO, the only thing that you need to do is to download the YANG models from the device and perform a compilation process using the NetConf Net Builder. There is 0 lines of code that you need to write or that we need to write in order for NSO to be able to start communicating or configuring your device. This slide is slightly dated, maybe about 1 year old. So the numbers may likely be outdated already, but the point I want to highlight is that in the case of NetConf, there's 0 lines of code required. But in the case of other interfaces, let's start with CLI. You first have to handwrite the YANG models with annotations. The annotations will spell out sort of the behavior of the CLI. Remember, this YANG model is being used by NSO to store the device configuration information into a CDB in order to make all devices in a network to be consistent, to have the same look and feel to the service manager. You then need to write the code to log in, to recognize the prompts, the error messages, and pass the state data. And as you can see, the kind of net that we have built in the past include iOS XR to deal with 60,000 leaves, there's 6,000 lines of code, and so forth for the other devices. And then now when you move on to other interfaces, again, you start with handwriting your YANG models, and then write the code to deal with how to access that device. So you still have a lot of codes to write. Maybe not, well, it's hard to say. The number of leaves are smaller. I was going to say that you write fewer lines of code, but maybe it's about the same, or maybe even more. But the point is that there's a lot of code that needs to be written when the devices support interfaces other than NetConf and YANG. Now let's go into the tutorial of NSO a little bit, just to give you a flavor how to work with how to start working with NSO. You first need to install it before you can run it, right? So NSO comes as a self-extracting binary. So you would run it as a shell script, and it will extract itself into the path that you provide to it when you run the installer. So after the installation has been performed, when everything gets copied into your install directory, the first thing you do will be you want to source the NCSRC file, which sets up the environment for you and all the paths, necessary paths for the binaries or the executables that you would need to be using, such as the NCS setup. As with everything else, the first thing that you need to do when you start working with NSO would be to create a project. So NCS setup, in this case, when you specified it with no netsim, and then the destination directory, no netsim tells NCS setup that there's no need to generate a network simulator behind it. You want to be able to talk to a live device, not a simulated device. So in your cases, all of you should be using it this mode if you want to be testing your NetConf implementation. And then what is under that project directory? What is notable here would be the logs would be where you go and look at logs information if you run into issues, or you want to learn about how the tool is operating or running behind the scenes. NCS CDB is where the YANG schema information, the configuration data store that I mentioned earlier that NSO will store. NCS.conf is the configuration file for the instance of NSO that you will be running. And then packages will be any of the nets as well as the add-on packages. All of those will be stored here. And then state would be a lot of the state-related information, including the ones that is generated by the NetConf NetBuilder. Those will be stored here. So you want to change directory into the project directory that you just created. And then you type NCS, which will then run an instance of NSO for you. By the way, for those who may not know why we use NCS, NCS is the predicate of the original name of NSO. But after we changed the name to NSO, we just preserved the command names to be the same as before. And then what you would want to use for your testing would be the NCS CLI. It's really a network level CLI that would be very familiar to you if you are familiar with how to work with CLI on CLI-based devices. If you specified it with the minus capital C, that would have the Cisco style CLI. And then you want to pass in the default or the default user that has been set up for admin. That would give you all of the capabilities that NSO gives you. Now, if you would rather run NSO and Docker Examiner in a Docker container, we do have the recipe available for you in this GitHub location. The only thing in addition that you need to do would be to download the Linux flavor of NSO and add it to that after you clone the GitHub into your local machine. Then at that point, you would be able to just run the scripts and it would generate the Docker image for you. And one of the biggest benefit with that would be that you no longer need to worry about the package dependencies. So what is described in our user guide, I think one of the chapters, maybe chapter 3, there are a lot of things that you need to make sure that it's installed in your host machine before you can make use of .NET Examiner. So all of those will be taken care of for you if you use the recipe that resides in this GitHub location. Now, next, after you get into the NCS CLI, if you want to connect NSO to start communicating with your device in order to build a NetConf net, you would want to set up the authentication group for your device. So you use devices, auth groups, group. So you can see this sort of as a profile that NSO will use. When you associate this profile with the device that you will be creating next, then NSO will know what username and password information to use when it connects to your device. So after the devices auth groups group command, you would then do a commit. It will create a transaction, and then this information will be stored in NSO CDB. After you have the auth group created, then you want to create your test device. So you would use the devices device command, and then you give it a name called device name. Device type, you'll be working with NetConf device. Now the initial net ID should be NetConf. The reason that it's just a generic NetConf net ID at this point is that the YANG models that's being supported by your device isn't yet known to NSO. If you give it NetConf, then NSO will be able to send the get schema request and hello exchange to your device in order to allow it to start building the net. Then next, you would set up the address information and the port information and the auth group that you just created. And then you want to unlock the admin state that would allow NSO to communicate southbound to your device, and then commit. Then lastly, you want to fetch the host keys that would allow NSO to be able to establish connections to your device over SSH. Then next is the NetConf net builder. So using the NetConf net builder, NSO will automatically extract or make known to you the set of YANG models that are being supported by your NetConf-based device. Since this is not a tool that would be used by a typical end user of NSO, so it's considered to be a developer tool. That's why the very first thing that you need to do whenever you need to access the NetConf Net Builder functions, you will use the DevTools command and set it to true. So the NetConf Net Builder, you first create the project. You give it the name, the version number, the device that NSO should use to connect to the device in order to perform the get schema request on, and then you also specify the vendor that NSO will use when it creates a name for the NetConf Net. And then you commit it, then you created the project. If you perform a show command of the project, you will see the download cache path and the net directory path. The download cache path is where NSO will keep the YANG file information that has downloaded from your device. And then the net directory path is where the actual net will reside when you perform the build net command. So NetConf Net Builder. So I'll just quickly run through this because I will show this again in the demo. So first, you would want to fetch the module list. This is to find out what modules are available on your device. Then you will select the modules that should be included in the NetConf Net by using the select command. And then you want to check the status to make sure that everything gets downloaded before you run the buildnet command. So the principles of module selection, you want to select a unique set of YANG modules that doesn't have overlapping data nodes. What does that mean? So let's say, for example, if your product supports both standards-based and native models, and if they support the same functions or same features, you want to make sure that you choose one or the other when you create a net. You can certainly test both, but then you would need to create two nets for them and test them separately. Because you don't want to see that if you change one leaf node in the standard space model and see the changes in your native model, that will confuse NSO, right? That will be considered as a side effect. And any selected modules that you have done in the previous step, all of the dependency modules will be automatically included, meaning that anything that you imported, it will automatically be included, because otherwise it won't be able to be built. Then, as I mentioned, so you do the build net command, then you check the build status. Then if the build status is success, then you go ahead and export it as a tar file, as a compressed tar file, and then you would want to move it to your packages directory. Then everything that's stored in the packages directory, whenever you go into NCS CLI, you do the packages reload command, it will go through the packages and load them as necessary if they haven't yet been loaded. And then the last step would be to update the net ID. Remember previously we had given it the generic NetConf net ID that really has no knowledge of the YANG models that are supported by your NetConf device. So now that you have built a NetConf net for it, you would want to set it to the NetConf net that just got built, and then you can commit it. Now, if you run into issues, warnings, errors, and here's a list of commands that would allow you to check the the errors and the warnings and what have you. If you need to be correcting the compilation issues, there's no need to go and update the device right away. The cache path that I mentioned earlier, you can go and edit the YANG models there, and then we build the NetConf net. Or you can export it into a separate project. That way you will be working strictly outside of NCS CLI, and then you will be able to easily go back and forth between making changes in your YANG models and rebuilding it using the make command. That would be recommended if you are running into quite a few issues that you need to address. So now let's talk about the device manager. So the important functions of the device manager for you when you are doing your NIAT texting is the sync to, sync from commands, meaning when you do a sync to, you are synchronizing the information that's stored in NSO into your device. Sync from is the other way. So when you first connect your device to NSO, you probably want to do a sync from. That way you don't overwrite the information stored on your device. And then config allows NSO to perform a diff between what is stored in NSO and the device. So here's sort of the syntax of what that looks like. You go into the config mode. You can also do that in the operational mode. Devices, device, the device name, and then either sync to or sync from. Compare config, that is something you will need to do in the config mode. When you do the compare config, you're comparing the differences between NSO and your device. And then you also use the device manager to make configuration changes on your device. Here's the syntax of how to do that. And you can also, if you have the configuration information stored in an XML format, you can do a load merge command of the XML file. And the way to detect side effects on the device is you first perform a sync from operation onto the device, from the device onto NSO. You then change the device configuration through NSO. Or you can do it some other means, but then you have to make sure that you do well, no, actually, in this case, it's best to do it for NSO for the purpose of this slide. And then after you complete that, then you do a compare config. If there are differences, the diffs will be shown in this format for you. You can also choose to display it in other formats such as XML. Now let's talk about the .NET Examiner package. So this is a NSO add-on package that's available from this GitHub location. And it provides the automated NETCONF and YANG testing of the transactional behavior of your device. So as I mentioned at the beginning, your device needs to be able to accept any valid configuration, regardless of its current configuration or operational state. There can be no autoconfig. And in order to get good results, you need to specify a good selection of input configurations, meaning those that are meaningful to your customer and that they are real-world use cases. And the way you set it up to use .NET Examiner is that you can either configure the device using NCS CLI, or you can configure the device outside of NSO through some other means, including CLI. And then when you are happy with that particular configuration state, then you want to perform a sync from command on NCS CLI. That way, NSO will have the most current configuration information in its status store. Then after that, you can use the .NET Examiner record state feature in order to record the state's name. In order to record the state and store it as a state name, a test state name. And then there are different ways to work with the state transitions in .NET Examiner. If you execute the Explore Transitions feature, it will go through all possible permutations of state transitions between any two states. So let's say if you have defined 4 test states, then it would go through 4 times 3 or 12 state transitions for you. And if you run into any issue that you want to repeatedly going back from one state to another state, you can do one state transition at a time by using the transition to state command. So that sort of concludes the tutorial portion. And then I'll conclude it by giving you some resources. So EANTIC, as I mentioned, the European Advanced Networking Test Center, they work with different vendors to do NETCONF and YANG interoperability testing. Well, they do other things as well, but one of the things that they do that's relevant to us would be the NETCONF and YANG interop testing. In the past couple of years, they've been hosting spring events every year right before the MPLS SDN NFV World Congress that takes place in Paris every year. So their spring test events will happen right before that. And during the event, different vendors that consist of service orchestrators, controllers, as well as NETCONF-based networking products, they will participate and perform testing on real-world use cases, right? So they will go through and configure the devices using NETCONF and YANG, and then they will actually set up network services. So they will test both things, right? It's not enough to just be able to push down YANG configurations onto the device, right? You also want to make sure that as a result of that, that some network service is actually carrying some live traffic. And then starting with this fall, the upcoming November 16 to 20, there is a fall event specifically for transport network-specific YANG models in interoperability testing. So if you're interested, feel free to go to this website, this URL, to learn more about it. Again, we really encourage all network equipment vendors to participate in this type of interop testing. We really want our network to be truly programmable and be automated from any vendor's products. And the results of this interop event will be published in white paper, live demos, and press releases. And lastly, this is the NIAC program. So we have the NSO software that can be downloaded for free for non-production use, and then the access to the NETCONF and YANG automation testing user guide. We also have an interactive demo that you can run through to learn more about the how to work with the tools. And then lastly, for your information, we have also written an application note on how to migrate from CLINet to NetCompNet to help those that are working with devices that initially had a CLINet, but now that the device supports NetConf, you can follow this procedure in order to do the migration. Okay, so let me open it up for questions. So Nabil, are there any questions for me to address?
I think some questions were assigned to you, Wei. Could you check your my Q&A?
Okay.
Yeah, also, if anyone has any questions now that you want to get a quick verbal answer to.
Okay, so let me read the first one. Please highlight the difference between NIAC and PI-ATS Jenny Cisco both are meant for automation testing. Well, I am not very familiar with PI-ATS and Jenny, but I understand that PI-ATS is a automation test framework. But I think the difference here is that with the NIAC program, our objective is to help equipment vendors to catch the sort of NETCONF and YANG interoperability issues. We are not so much focusing on allowing equipment vendors the ability to perform automation testing to let's say if you're testing the setup of a service on your network, the NIAC tool will not check to see whether traffic is up or not, right? At the end of the state transition. So I would say that would be the main difference.
I think the answer also is, in addition, is that the FIAS address test and verification automation, whether NIAP is focused on NETCONF and YANG standard compatibility. Connie, thanks, Connie, for that answer.
Okay.
Okay.
So let me look at, are there similar examples for basic device config for Juniper, Nokia, and Huawei? Okay, well, there's already an answer by Connie. I believe Juniper, Nokia does a good job of providing. Yeah, a lot of times the typical configs you can search on the internet, on the vendor's website. They would usually have a configuration guide that you can go and look at. So Nabil, I noticed that the Q&As that are assigned to me already have answers to all of them, right?
Yeah. I think if they were answered, then that's good. We covered all those questions. We can move on to the next section.
Okay, maybe just the last question. We have a lot of defaults in Yang, especially when an interface is created. There are a lot of defaults associated with it. In our system, creation of 1,000 interfaces takes around 6 minutes. I don't see a question here, though. Is the question that?
I think that question came after a question on performance. How do we handle default values when you have a large Yang model and you have a lot of default values, right? And you're pushing that configuration from NSO. Let's say you just want to apply the defaults. Will it send those defaults again in the request? And I guess the question is with regards to performance and the time it takes to apply values that are default values.
Well, I think if the device supports the default handling capability, I mean, it's not, and the NetConf clients or service orchestrators should not send the default values.
Right.
So default values is not going to slow it down in those cases.
Right. You have more questions there, Wei, but feel free to pause the questions and we can go to the next section and then go back to the questions. So up to you.
Okay, let me go into the demo portion because I want to see if I can get through my. I have 3 demos planned. If I have enough time, I'll run through all 3 of them.
Okay.
So let's see. Okay, the first one I'm going to be running is sort of a little bit of a toy example from the device side. It makes it easier for me to illustrate the concept or the sort of issues that can be caught. Certainly, in a real world situation, your test states or test configurations should be a lot more complicated than that. So I have a couple of devices that I'm going to be using. They are all powered by Confi. So by the way, if your NetConf implementation is done using Confi, you certainly have a leg up there that a lot of things should work for you during the testing. I have some scripts that I'm going to be just copying over. That way it saves me from some typing.
Wei, could you increase the font size, please?
Okay. Is that better? because I want to be able to show the log files as well. If I make it too big, I won't be able to do that.
Yeah, I think that's good.
Okay, so what I just did is created the project as I mentioned in one of the slides, and then I changed directory into that project that I just created. And did I already execute NCS? I was changing the font size, so somehow it duplicated. Okay, let's go into, so NCS has been started already. So let's first install the .NET Examiner package. So I'll do a git clone, and then I also build it. And we can then start up a NSO CLI session. If I perform a packages reload, reload command, NSO will go look through the packages that's available under the packages directory and load them. So now .NET Examiner has been loaded. And then while I'm at it, I'll just go ahead and configure it. So I'll set the values that we have recommended in our user guide. And I also set the devices global settings to trace spreader, meaning that whatever device that my NSO session connects to, it will create trace files for them, netconf trace files. Then the first demo I have would be the test 1A demo. So let me show you the YANG model. As I said, it is a fairly simple YANG model. So it's just one of the DHCP daemon that you see a lot when you first start learning about NETCONF and YANG. But it's good enough for me to be able to illustrate the concepts. So let me go ahead and run it. And so now the first step is to create the auth group. So I'm calling it NIACT. Admin. Our devices uses the default username and password of admin. And then in the same transaction, I can create the devices as well. Oh, I haven't yet completed this. And then now let's commit it. And then let's fetch the host key. So that part's done. So now what this does is it configured netconf with the net ID of netconf, the generic net ID, that would allow us to communicate to the device to retrieve or to fetch their YANG models. Oops, wrong screen. Then let's go ahead and enable the DevTools. And then I just created the NetConf Net Builder project for it. I'm calling it the TelWeb DHCPD. That's the name of the net, and then version 1.0, and then connecting to the device test 1A. After you commit it, then you will be able to start working with the project. The first thing I can do is to fetch the module list. It will gather the list of YANG modules available. And then now if I access the module command, I will see the entire list of YANG models that are being exposed by this test device. Since I'm only interested in the DHCP daemon YANG model, I'm going to be selecting that. This is a test. Since this one is an example YANG model, it doesn't really have a revision date. Otherwise, when you are working with real world examples, they should have a revision date. So I would use the select command to select the YANG models that I want to include in the net, and then I do a build net. After you build it, you want to check to see that the result is a success. So as you see, it will show the net that has been built and the build status. Now that it's built, then what we want to do is to copy it or export the net into a folder. So you can sort of ignore this error message. It's complaining about some ownership issue, but it would actually copy the file for me. If I show you here, let me do a -L. Oops, I added something at the end. Yep. So 1108, it just got built. So I'm going to be moving it to the packages directory. Oops, I'm not the right place though. CD and CS. So move temp and CS into the packages directory. We can also look to see what's there. So .NET Examiner was placed there earlier, and now we put a new net over there. We can issue another packages reload command. So now it's reloaded. And you see a new package being loaded over here. And then let's go and fix up the net ID that we need to be doing. So over here, I go into the config mode. I change the generic netconf net ID to the one that we just built. I did a commit, and then I did a sync from. Now with this new sync from command that I run, NSO is already aware of the YANG model supported by this device. It will be able to store those information that's being returned by the device in NSO's own data store. Well, in fact, NSO will only issue get config requests on the YANG models that it's aware of. It's not going to blindly retrieve everything because it doesn't want to be retrieving data that it has no knowledge about. No, that it doesn't have any understanding of. So now let's start working with .NET Examiner by first initializing it. And then I have a bunch of states that I have planned for. So they, as I said, they are fairly simple states. So in the first case, I just changed the log facility to current. A lot of these have default values, but I'm just setting them to a specific value right now. And in state 2, I just change it to another log facility. And then with state 3, I'm just adding a subnet. And then with state 4, I'm just changing the shared network name. So I created a total of 4 states. So at this point, this device is working as expected in what I call the normal mode, but I want to put it in the error mode. That would allow me to show you the sort of issues that we can see as you run through this tool. And then as we do that, it would be more interesting to look at the log files. So let's look at, there should be a netconf trace file. So let me do a tail -f. So this is the netconf traces of the netconf communication between NSO and the device. And then the other file that I want to show is the log file of the DoctorNet examiner. And that way, if something happens, I can explain what they are. Then the first thing I want to do is to show you the validation dependencies, the ability to be able to move between states. And if it was valid in the past, it should still be valid in the future, right? So let's go ahead and exit out of this. DoctorNet examiner, state transition. So let's go on one state, on a state-by-state basis. So let's first go to state 2. I will walk you through some of the log files since right now it's working as expected. I don't want to take the time to discuss the log outputs because there's one that would take a while. I'll take advantage of that time to delve into the log files. So now let's go to state 1. Again, it's a success. Then now if we go to state 2. So let me talk about how the DoctorNet examiner tool works. So first, it will gather the device current information and store and store it. It performs the sync from. So you see that as it goes to state 2, it will load the state 2 information here. It first empties out its config, and then it does a load merge of the command, making sure that it's only sending out the deltas, the minimal set of deltas that it want to send down to the device. Then once it figures that piece out, then it would do the commit command. Then the commit command, you will see the edit config request here, that this is the command that it generates. And then in this case, I artificially injected an error onto the device. So it would track the state transitions that the first time you go to state 2, it would allow it. But then if you go to it the second time, it will reject it and complain that the resource is denied. And the reason why it was taking a while for the test to complete is that we are making use of the commit kill feature of NSO. So because it's a resource denied issue, NSO would attempt to do the commit again. That's why if you try this, you will see that it's being done twice. So at the end of the results, it will always perform a compare config just like the slide that I show you, how do you figure out side effects? So you can always go back and see what type of side effects that you see. So we can do it live here as well. So this is the kind of side effects that you will see. And now that we got the first one done, so let's do a sync from. And let's make sure there's no difference between the two. And then now let's transition to state 3. Now this one is going to show side effects. So again, you notice the failure here. So if we let's scroll back down, scroll up, you will see the plus sign here, meaning that the device has done something extra. In addition to creating the subnet, it has also changed the max lead time to a new value. So that will be considered a side effect. So if you are interested to see how things look on the NETCONF trace file, I moved beyond that already. It's sort of small. This one, maybe I want to increase the font a little bit. So again, if I do a compare config, you will see the plus sign here. So this is consistent with what we're seeing. And then the last thing would be so in order to get out of this situation, what we can do is to send down the config request to change that value, right? That way, it will now make the data store between NSO and the device to be consistent. If we now perform compare config, then it's the same. Okay. Then lastly, it's just let's go to state 4. This one will try to set a leaf value, and then the validation callback will just reject it. If you're familiar with ConfD, I put it in a validation call point to just deny that, even though it's something valid. If you look at the YANG model, I'm setting the shared network name to something that is valid depending on the YANG definition. I'm changing it to this name, but then it's complaining that that is not a valid name. So that's sort of the third category of issues that gets caught. Okay, so if we do a compare config, then we will notice that this thing it has never. So we can do a sync from, and let me put this back to the normal state. Let me not go through all the possible state transitions now, because we will be running out of time. Let me go and execute the last one. I don't think I have time for the second demo, so I'll skip to the third one. So this third one would be showcasing a more real-world example. I will be talking to an XR device. So let me go and set up NSO to work with the XR device. the first thing I want to do is I want to update NCSConf file, CLI. I want to give me the ability to be able to, oops, I don't need CLI here. This will allow me to be able to easily copy and paste into the CLI session. So after I updated that, NCS reload. Oh, there's one. Let me do it here. Okay. So now that we get that taken care of, I will create the device. Oh, I missed the, how did I miss the D? Okay, so over here, I created a device into NSO and connecting it to a virtual XRV 9K device. Again, using the generic NetConf ID. And now that I created it, I can go ahead and look at the trace file. Oops. How come? Oh, I haven't yet done a sync from, I think. That's why it hasn't yet created it. Let's do that first. At this point, the sync from will not have any product-specific information in its config in its get config request. So that allows me to look at the NetConf trace file. And then if I go and look at, oh, let me not look at that one. Maybe it's just more important to look at this one. Okay. So the net. So I created a project, a NetConf net project. And then let's go ahead and show it. Oh, I haven't done a fetch module yet. Now, at this point, I already know the modules that I want to include. So I'm just going to go ahead and select that. After it's selected, I want to look at the status. I hate it when I miss the first character. Oops. These are the modules on the, but what I want is the module status. So everything has been downloaded. So I'll go ahead and build it. And I'll export it to the temp folder. TMPACS. So now that it's built, it's called the XR Mini. I'll move it to the packages directory. And do a packages reload here. And then I would do a XRV 9K. Let's update the device type. So now when I do a sync from, this will give me the information related to the YANG modules that I have included. So if I do a show running config, then you'll see the device configuration. But looks like I'm running out of time. I was going to show you how maybe I can show it at least the files, and then I'll leave it at that.
So Wei, yeah, since we have 2 minutes, maybe you can do that, and we can just open it up for questions. Good thing is all the questions have been answered so far, but there might be new questions coming up. So.
Okay. Oh, I'm looking at terminals. No wonder I couldn't find a file. So this one. Okay, let me share my. So as you can see the file here. So what I did not have enough time to show was that in this case, well, previously the way I recorded the states, I did the configuration from NSO, but now with this one, my my thinking was going to be updating the XR device through the CLI commands. And then once I do that, and then I do a sync from on the NSO, and then record state that way. So that was what I was going to do. I can certainly include the information somewhere for those of you that are interested. That we can make that available since I'm running out of time. Okay, Nabil, I hand it back to you.
Yep, sounds good. Thank you, Wei. Can you take a look at my Q&A? I think we answered and covered all the questions. But if you see anything there that's pending, then that's pending and needs to be answered. So I don't think you will see any questions, right?
Yeah, I don't see anything. I think they have all been answered.
All right.
Well, thanks a lot, guys.
Perfect. Mm-hmm. Thank you. So when we end this meeting, you will be redirected to the browser. 2 pop-ups will show there. If you could please answer some questions there. I'm also going to redirect you to the guide in NETCONF and automation testing guide. If you're interested, please register, and we can reach out to you after that. All right. Thank you, everyone. Take care. Have a nice day.
Okay. Thank you.